Today's topic is unlocking CER visibility, uh, ensuring resilience and sustainable electricity supply. Dr. David Mills, Head of Consulting, and myself, Yogendra Vashishtha, Head of Future Networks, we will be conducting the webinar today. So today's agenda, we will be discussing Australian context and some global insights in this area. And then we will share with you 2 UK case studies and 1 Australian case studies, and then we'll have time for Q&A. In terms of the global insights and Australian context of CER, Australia is using more of CER, which we can say is a subset of DER, distributed energy resources, but CER, the consumer energy resources, or own behind the meter distributed energy resources, we can say that, like rooftop PV, batteries, and electric vehicles. And Australia has very high penetration of these CERs, and it is growing. And these distributed resources have inherent flexibility, both in terms of the generation and load. And it is already providing efficient solutions in terms of the reliability and also in terms of the network security, and also helping the net zero transition. But the condition is if these resources are harnessed properly through visibility and capability, they should be capable of being harnessed. So in that context, generally, the technical capabilities, customer participation, and the availability of a flexibility marketplace are important. So what I'm actually here presenting to you is the flexibility marketplace, which will allow this participation of consumer energy resources through appropriate remuneration process and alleviate the congestion without inefficiently augmenting the network and support the power system instability or ensure the power system security. Now, when I say market design and development, it includes the roles of every actor in the market, which we are calling TSO, DSO, coordination of these resources, dispatch, decision making to dispatch, clearing houses, digital infrastructure where the information can be shared, and the flexibility service providers, of course, and market architecture, which supports or enables everything which we are talking. Now, you must have seen that latest statement of opportunity from AEMO. I just wanted to bring to your notice, let's say the middle graph, which is like our aspiration. And in that middle graph, if you see the purple lines, these are the coordinated CER projected. And this is quite significant. So to achieve that level of coordinated CER, which can be done, again, I'm saying if harnessed properly through the visibility and capability, it can be achieved. And AEMO is forecasting that approximately 85% of the CER will need to be coordinated by 2050. So they cannot be just passive and just doing one function for the consumer. They have to support the network and the market to actually realize their full potential. As you know, that Australia has increased more than 4 million rooftops already installed. Now there is a national CER roadmap, and there are 4 streams. The CER task force is working on the consumer side, technology, market, and power system. I'm just demonstrating you that in Australian context, in this CER space, this work is already progressing. And if you see the number 3 as market and M2, which is saying data sharing arrangement to inform planning and enable future markets. So there's work happening on that. There are service streams like M2.1, 2.2, 2.3, which is talking of what is the data access right, what is the operational CER data for dynamic operating envelope required, the consumer data, the privacy, all these things are at the moment being worked out. Now, EA Technology did a project for EEA New Zealand, and we actually scanned all the flexibility projects, initiatives, trials in New Zealand and overseas, like Australia, US, Europe. And we mapped them actually for those who are more focused on technology development, network management, customer engagement, and market design and development. Basically, every project and trial has all these four elements, but which was the focus? What was the focus of that particular trial or project of flexibility initiative? So as you can see that New Zealand, it is more of, red and brown color, which is network management. So all these initiatives are around, network management. But if we see the international one, the blue color is very predominant, which is market design and development. And I think we identified 100 projects, and majority of this blue color is coming from European market, from Italy, from Germany, from France. So basically our observation was that while we are actually in Australia, New Zealand doing a lot of work on technology and network management, we are doing, in Australia, there's a lot of arena funded, very large projects which are doing on market development, but generally Europe is actually quite active on market design, development, and architecture. That was one of the observations from that study we did. This is just a summary. There was a project called Be Flexible, which is like 10, 12 pilots together. It's something like what we have here, Race 2030 or something like that. So in the second column, if you see is market-based procurement of flexibility implemented, it says France has, Italy not, Portugal is trying, Spain no, Sweden yes, United Kingdom yes. So with Piccolo and flexibility services, that UK already procuring those services through the market. There's another project which is called Syntec in Germany. That project is actually a smart grid testing the flexibility market concept and leveraging the flexibility from DER, demand response storage. And the outcome of that project is that market-based procurement is feasible, subject to standardized product definition. And this is very important. This will come again in this discussion, that if it has to work like a market, it has to have a standardized product definition like upward flexibility, downward flexibility, minimum bit sizes, location tagging, TSO, DSO data exchange, protocols, and adequate customer reward and trust. So this will definitely come up as a requirement. The project Syntec tried a lot of local flexibility markets, and it actually piloted the TSO DSO coordinated procurement schemes to avoid conflicting dispatch decisions. So here it is that whatever we name it, but conceptually that flexibility market has to manage the TSO and DSO requirements and avoid the conflicting dispatch decisions. And then there is another important thing is this establish the flexibility clearinghouse, which is digital neutral market platform where flexibility bid were collected and matched with TSO, DSO needs. That neutral market platform is important to note because that gives the trust because of which the customer can are ready to give the control of their resources. And as I said earlier, the standardizing the flexibility products is important. The another project which I referred earlier, the Be Flexible, it is a 12 pilot sites in Italy, Sweden, Spain, and France. This one is more around building the grid data and business network like a hub, data hub, where everyone is actually, can share the data. I'll show you some of the architecture of this, but I'll not go into the details. It basically is saying that the data in that hub, which GDBN, is coming from communities, coming from aggregators or BPP providers, and from cross-sector loads industry. And the aggregators are getting data from regulator, from flexibility market, DSO, congestion kind of thing, and from TSO. I will now hand over to David Mills.
Thank you, Yogendra, and good morning, everyone. So I am going to present today a piece of work we recently delivered for the National Infrastructure Commission in the UK. And this was aimed at helping them to understand what the investment need in distribution networks was and how that varied across voltage levels and the role that flexibility or getting participation from demand side resources into the market would help to defer that investment. This effectively all around how to tackle the uncertainty in technology uptakes, UK based, so the uptake in EVs and heat, electrified heat being the greatest concern, but the same modelling approach and analysis applies for more generational or PV-led challenges. So first of all, we did this analysis to support the UK government using our transform model. So for anyone that's not heard of this before, this is a parametric model that we have built in lots of countries. In the UK, it covers the entire country. So we have representation for 19 different low voltage networks, about 12 different high voltage networks, and then sub-transmission as well, broken down to different network archetypes. So taking all those network parameters, we're able to model where the challenges are going to be experienced on the network, and then we apply on top of that different uptake scenarios. So how many rooftop PV are going to be installed, where are they likely to be installed, where are the greatest uptakes going to be, what happens when they start to cluster, all these sorts of test cases. And then we can understand when the electricity network starts to run out of capacity and or starts to have voltage issues or fault level issues, and test different solutions to solving those. And all this analysis gives us an investment profile over time, but lets us pull different levers and see how that impacts that investment or the different constraints and challenges. So as I sort of summarised some of this before, it lets us understand what the size of the problem is. It lets us test and identify potential new solutions, alternatives to just putting in bigger transformers or upgrading circuits, but also highlights when that's the only option, and then lets us test what different scenarios would drive that, so you can help to understand the kind of least regrets options. So we cover LV, HV, and EHV networks. We do some 132 kV modelling as well as part of this, and it lets us go right down to really rural or really urban apartments, rural farms, agricultural analysis, to understand how local variations and clustering affects that. And then we can test different kind of engagement from customers. So are we going to have high CER uptake? What's needed to enable that? And then how does that actually respond and participate? So for this particular case study, we were testing a range of different customer low carbon technologies, DERs. So we had solar PV as a generation. We also had wind and a little bit of run of the river hydro as our generation sources, on top of kind of the base generation that's already there. We were then testing electrified heating. So this is the particular study that the National Infrastructure Commission was interested in, and their concerns, so understanding different types of heating, uptake of different technologies, what the impact of that would be, and then all the standard kind of challenges around electric vehicles, where they're going to connect, how they're going to charge. So for each of these, we have different profiles accounting for diversification that we use to model the behavior of the impact on the network. So obviously a large amount of data there that we have to ingest. And so this was tested. We did a total of about 15 different scenarios for this project, but some of the key ones here were aimed at testing the difference between low and high flexibility uptake, low and high participation of consumer devices in supporting DSOs or DNSPs with their constraints. So the core scenarios on the left, the FES 23 and NI2 are specific scenarios determined by NISO in the UK. And then there are a couple of extreme cases. So for us, it was extreme cold, when you get a prolonged cold spell and you start to run out of your kind of customer willingness to offset their heating, and what happens when that starts to fall over. And then we did some additional sensitivity looking at data centers and energy storage and how that could impact the total investment cost. And then in terms of flexibility, so we had two different types of flexibility. We had what we called implicit flexibility. So this is customers that are probably responding to price signals around wholesale market imbalances, times of day when there's cheaper energy, and reflected typically through some sort of time of use tariff. And then with explicit flexibility, so this is where we directly send signals to request a customer shifts their demand. Some of the managed EV charging trials we've been delivering have actually tested this, and we're seeing good responses where customers are willing to let their charging be controlled by the operator or their retailer in response to a lower tariff. So one of the kind of big bits of analysis that our modelling lets us pull out is what's going to be the total demand or total generation, peak demand, peak generation each year out to 2050, which is the end of our modelling run. So here we're showing a kind of shift in energy demand curve that we're expecting. Higher peaking in the morning up to 120 gigawatts, so doubling what our current demand is. Where we got some unexpected and challenging results is when we looked at that winter stress case. So this is simulating a 1 in 10 year cold spell, and actually reckoned that we would have to have capacity to deliver 155 gigawatts in those conditions. So that really starts to sort of open potential for where your flexibility could actually help, and where we might need more energy storage systems or ability to pull down in larger demands such as industrial combustor to enable heat in this case. You can get the similar kind of challenge around connecting air conditioning and things like that in hot spells. But one of the values we get from the analysis we do is we're able to really dig into this investment. So we quantified that there's about £40 billion by 2050 needed just to deliver enough capacity to distribution networks, which is, doubling our historic levels of network investment. But nearly 65% or nearly 70% of that falls on the LV networks. This is where we're seeing all the new customers connecting their rooftop solar, their electric vehicles, their heat pumps. We're getting a growth in air conditioning. And that's huge amounts of small local upgrades, which currently have very limited visibility. And this is all kind of expected to really start to ramp up in 2030, 2040, which is the regulatory cycle that we are currently preparing for at the moment. And this is where flexibility or customers' kind of engagement participation really help to support, I guess, the networks here. So one option was, you can actually just reduce the investment cost. We managed to reduce £7 billion of investment, which is a huge saving to consumers. But it really helped us to smooth that investment profile. And one of the growing concerns that we are seeing is around how does the supply chain deliver sufficient capacity here to actually have enough assets to install. And so really showing the potential there for customer side flexibility and participation. But we can then take that one step further. So the second part of this project is we actually got right down to modeling some low voltage feeders. So again, using one of our software tools, we are able to model with actual DSO or DNSP data, LV feeders, and then simulate the uptake of different technologies and see when they start to struggle, when they start to fail, and then test different solutions again. And because we could go down to this level, we were able to really demonstrate what some of the first solutions were, where it's thermal challenges, where it's voltage challenges, but also what happens in the future. So the opportunities for customers' flexibility to actually defer, and the cases where it just isn't, where you're going to hit such an uptake of demand in an area that you need to get straight on and do something. And then there was also combinations where you can use transformer upgrade and then some presumed future customer flexibility just to peak loss and avoid the bigger transformer. So digging into all this data, obviously you have the flexibility, it's able to reduce it, but then there's still a level of network investment. As we said before, it's all happening on the LB network. That's where there's loads of small little upgrades, a few larger schemes, but that's going to be the bulk of the investment. And when we start to look into that, there's a huge amount of work spent on overhead lines, transformer upgrades, and network monitoring, something that we know if you want to connect more CER and get it working with the network, you've got to be able to see it and understand what's going on. So monitoring being a key enabler, data visibility, really understanding what spare capacity is or headroom there is on the network, and then being able to understand the value that flexibility, and we can break that down by rural versus urban versus suburban. We're down to 19 different archetypes, and then different voltage levels as well. So some of the key conclusions that we reported back to the National Infrastructure Commission that then went into their recommendations to the government and is now flowing into the next RIIO ED3, the next regulatory price control in the UK. So don't underestimate the scale of the challenge. We're looking at forecasting a doubling of demand for 2050, even with all the sort of energy efficiency work that's taking place alongside that. And that's going to bring unprecedented levels of investment, and a lot of that on the LB network. So some of the steer that we're now seeing is getting ahead, investing ahead of need. So we're seeing a lot more work trying to use modeling like this to justify anticipatory investment, getting the capacity into the network so that you can make the most use of flexibility and flexible resources, and basically increase the use of renewable generation and reduce the carbon footprint of the grid, but also combining that flexibility with reinforcement to help smooth out the investment pipeline. And we're seeing loads of work needs to happen now. The 2030 kind of delivery window isn't very far away. So, and some work that we're actually working on. I will now hand back to Yogendra, who's going to run through Australia case study.
So just sharing one case study from Australia in this space, which you are all aware. So Project Symphony was a big one, which orchestrated the CER data into VPP, 500 households, 900 assets. And it did a lot of scenarios like balancing market, network support services, net zero, essential system services. There are good recommendations from this to learn. That's why I'm sharing this. And you must be aware that this has been, the learnings of that, insights from that has gone into the project Jupiter, which is a very huge project, which is already underway through arena support. Now, the reason I picked up that is it has those recommendations which supports what we have been talking. For in Australian context, it says adopt a single communication protocol. So because Australia has gone for IEEE 2030.5 and CC to control the devices, to have that protocol ready for dynamic operating envelope as well, in comparison to some of the jurisdictions who might be trying open ADR and other open communication protocols. So yes, this says, use a single communication protocol for all the inverter-based DER to ensure the interoperability. Then, as in the case of Europe, there is a need here for business for a DER data hub, where DSO, DMO, aggregators, even TSO, can exchange the data freely for that marketplace to function. And then it is saying they provide simple, transparent, accurate, and timely customer-facing information on VPP. And this is very important. It has come a couple of times now. Is that the information, the how to participate in the VPP, what is there for them, has to be in a very simple and less complex manner so that the customer can actually participate in that aggregated marketplace. And end-to-end customer engagement tools, yes. And framework for third-party aggregators, yes. Visibility of VPPs for DMOs and DSO. So where is so that like the priority for dispatch, can be done properly. And then there's a incentivize aggregators to ensure the customer receive their fair share. So these are the recommendations from Project Symphony, which happened in Australia. I will just summarize, in terms of in Australian context, the CER is actually growing. And we have seen, everywhere. We have seen the UK case studies where it is happening, and largely they are connected on LV network. LV network was not great. It was deliberately not designed, telemetered, not designed to give that kind of visibility of what is happening on that network. It used to be the poles and cross arm and one transformer, and that's it. Even there was no, on-load tap changer or anything just to do the voltage optimization. It was not required. So now, because as David presented, more than 60% is actually, the investment is LV network. So it will require the visibility for that import and export to happen. And again, as David said, and we have seen in the AEMO report here, that while the large transmission projects are happening, and there is logistic issues, supply chain issues, permit issues, and to alleviate the congestion, even AEMO has recognized that this flexibility at a distributed level, at a low voltage level, can actually help and complement those efforts and minimize or optimize the total invest into the networks. And so there has to be visibility. The CER has to be capable of being orchestrated, including the compliance. We are seeing now, we have seen a lot of work on AS 4777.2 2020, which is now being complied. The compliance has actually improved. And then we definitely need a digital infrastructure where all levels of data can be shared, the equipment, system, marketplace, and ensure the interoperability, open protocols, and cybersecurity. So this is the enabler, the foundation part. Then operations, market design for coordination, dispatch, and settlement. So now AEMO has come out with the VSR, voluntary scheduled resources. So basically that document sets up for market design, how these things, all these scheduled dispatch can happen from those from the volunteered resource from CER. And then, as I said earlier, neutral empire between the flexibility market and TSO DSO requirement for customer benefit. And this will address the issue of trust and the complexity. The customer has to understand what they are going to do and before they actually give the control to others. And of course, the third leg is economics, the investment, the price responsiveness, and regulatory support for innovation and policy stability. So I think what I'm seeing is that it's not happening. The work is happening in all these things. So there are certain things which we require as a foundational or enablers in terms of the market operations, we require something. And in terms of the economy of scale and investment, to ensure the long-term investment, there are certain things have to happen. And this is already happening, it is progressing. Now, those who are interested, there are other resources from AIMO. We get every 2 years this ISP, and we already have that statement of opportunities, GPRS, GPSR, General Power System Risk Review, which is fantastic. The new one is the Voluntary Scheduled Resources Guideline and Managing Minimum System Loads. In our context for CER, the AS 47.2 2020 Amendment 2 is very important. AS 5438 for interoperability requirement. It might have come or it was coming soon. And then there are cybersecurity standards. Just any other question, anything you want to ask, please do contact us, me or David. Anytime, any question comes to your mind afterwards. Hope this has been useful. Thank you very much. We will close this webinar now, and thank you for attending. Thank you, everyone.